Welcome. Welcome to the Building Smart USA webinar series for June. Um, I'm Tony Rinella, and I will be wearing two hats for this webinar. First, as the host of the webinar, in my role as Education Director for Building Smart USA, I will be managing the webinar and introducing our speakers. Most importantly, my colleague Jim Bedrick, whom you can see right now. And also, I'll be co-presenting with Jim. Um, so somewhat strangely, I will introduce both of us and welcome us to the webinar. Let's talk a little bit about the webinar and the webinar series. Um, the first thing to say, on the left-hand side of the screen, please do visit our website to learn more about our webinar series. We have a QR code here that you can use to get quick access to it. We do publish information about our webinars in advance, and also if you scroll down to the bottom of that web page, you'll be able to see any of our past webinars on our YouTube channel. We do have a very exciting webinar coming up in July, which is by James Gray of Federal Highways Association. Very interesting to get us involved in horizontal infrastructure as well as vertical buildings. For today, thanks to Jim and the BIMForum, we are able to offer AIA continuing education service credits. So if you're an AIA member, then please be sure to put your name and your AIA number in the chat window of this Zoom session, and then Jim and BIMForum will make sure that you get your credits for today's webinar. If you have any questions, please put them either in the Zoom chat window or ideally in the Zoom question and answer part. We will facilitate questions at the end of the presentation. You can either just put your text of your question in one of those two windows and we'll read them off. But ideally, if you're comfortable unmuting your microphone, we'll make that possible at the end of the session, and then you can chat directly with the presenters. So those presenters are Jim Bedrick, FAIA. We'll ask Jim to introduce himself as he begins to speak. However, from personal experience with Jim over several decades, I'd just like to say that he has been a very important force, not only in developing the level of development that he'll be talking about, actually bringing it to life and making it practicable in the industry around the world. But also, he's been involved with the AIA Documents Committee for at least a decade and has experience as an architect, as an engineer, as a construction person, and as an owner-operator. So feel free to ask far-ranging questions of him, and especially on the topic that we're talking about today. So let's dive into that topic. Hi, I'm Tony Rinella, now in my co-presenter mode. I work with a company called uh, Strategic Building Innovation, and we look at ways to improve the value and data accuracy for built environment throughout the world. Because of this, we're very interested in information requirements and therefore are attracted to the level of information need, which is an ISO standard I'll lay the foundation for how that ISO standard is put together, and then Jim will show us practically how to implement information needs. Um, so this ISO standard talks about concepts and principles. It really tells us what we need to know to specify information needs, and it is applicable throughout the life cycle of an asset. I encourage you to follow the link or to use that QR code you see in the lower right to actually read the entire document. It's information rich and conceptually it gives a very strong background. We'll delve into the highlights of that ISO standard in just a moment. First, we'll relate it to some other concepts in ISO 19650, which are the various requirements for information that the ISO standard suggests we outline in order to get the kind of data we need to design, construct, hand over, and operate a facility. You're probably, in this audience at least, all familiar with the organization information requirement. This is how an organization talks about the data, the formats that they will need throughout the life cycle of their facility. Specifically, it helps outline the asset information requirement, which is used throughout the operation of the facility so that the owner or operator can understand a digital twin view of their physical asset. The asset information is updated throughout the life cycle of the operation of the building, and the information requirements specify what will be in the asset information model. Uh, Usually prior to that, there are exchange information requirements, and these are used to support the model uses that are outlined in the BIM execution plan so that everyone knows what information is required and when in order to put that data in the project information model, which is used throughout design, construction, and commissioning of a project to, again, have a digital representation of the physical asset. So let's take a look at how these different requirements are explained in the level of information need. Um, First of all, we understand that model uses, as identified in the BIM execution plan, give us the why for how we need or what information we need, what processes will be supported. The BIM execution plan will go on to say when the information will be needed and who's responsible to author this information. And also, of course, very importantly, what information is required. The level of information needs standard will help us understand what information is required in three basic categories: the geometry, the alphanumeric data, and the documentation that goes along with these. Let's jump into the descriptions that are provided. First of all, as we've said, the standard gives us concepts and principles. That is, what should we be thinking about when we're developing these information requirements? And what are the contents in these three different categories of information? We can take some examples. So for geometry, we're likely talking about the detail, that is, the complexity of the information. Is it diagrammatic or is it representational? Am I looking at some sort of structural diagram, or do I want to see exact placement, or do I want to do some kind of rendering? The dimensionality, which is not only the shape and size, but also the location point. How am I placing that in the model? And the location. Is it going to be an absolute coordinate with regard to the overall asset coordinate system, or is it going to be relative to some other object? What will the appearance be like? Is it symbolic, just a little icon that I find in a model or on a drawing? Or is it going to be realistic, something I'll recognize as a window or some kind of valve unit? And then will it have any parametric behavior, either because of where it exists in the built asset or because of something that might be an interaction with the objects around it? In terms of the alphanumeric data, this will include certainly a position within a breakdown structure like uniformat, and Jim will tell us a lot more about that. But in addition, there are the other sorts of properties we often think of as being associated with a building information model object, like its required properties. It might have a specific fire rating, or we might need to know the make and model of a piece of equipment. The documentation comes, excuse me, in a couple of formats. Um, for example, it might be a tracking mechanism used to make sure that decisions, approvals, and verifications happen um, related to that object, so that we know that we are in fact looking at the object description we want to have. But it might also include external documentation. For example, a structural analysis report on a particular structural element, specifications and manuals of things that we find in the built asset. So let's look at a quick example of how this might unfold in a real world project. In terms of why, let's say, for example, we're doing a structural analysis, and when would be probably several design analysis iterations that will happen at design review milestones. Who? Uh, let's hope the structural engineer is engaged in this process. And then what? Well, for example, if we're looking at a beam, we might understand that all that's required to do the structural analysis is a diagrammatic representation. In early days, that might be a 1D representation, just a note, or eventually we might want to have a 3D representation of the element, probably located absolutely in the project coordinate system. We'll want to identify the type of beam that we have, any attributes and performance characteristics that go along with that, and of course, we'll want to attach a structural analysis report. All this makes sense from a uh, procedural point of view, but then how do we actually accomplish all this? This is where our LOD comes into play. It provides practical mechanisms to specify the information we need. Um, we can do it in a tabular format, and let's learn how that all comes together. And Jim, would you like to come on and take us through the rest of the explanation of LOD?
Sure. Let me see if I can get everything turned on here.
All those buttons, yes.
Yes, the buttons. Okay.
Okay, and while Jim is pressing those buttons, thanks to all the people we have in the audience, just a reminder, you can put your AIA number in the chat window as I see folks have started to do. And you can also post questions, which we'll take later in the presentation. So, Jim, we are about to see presentation mode. We're still, there we go.
Okay.
Hey, great. Thanks, Jim. Take it away.
Thanks, Tony. Tony did a pretty good introduction. I don't have much to add to that, except that a thread throughout my career has been interdisciplinary collaboration. And originally, I started working on this, the LOD framework, as a language to help collaborate around models. So the way the framework works is, first of all, elements go through and systems go through the design process at different rates, right? I mean, usually the structure leads everything, things like interior casework and finishes bring up the tail end, but they all tend to hit certain common milestones. We probably start out with a concept that might be just a cost attached to a massing model. Next step is usually generic placeholders. We might have the floor in as a deck where the thickness is determined by some sort of rule of thumb based on the loads and the spans. We'll then get to specific assemblies, which are the actual members that we want in the building. And then we'll take some of them to details. As example, where the specs call for a shop drawing, we might take it to that level. So we labeled these LOD 100 through 400, and the AIA Documents Committee came up with some definitions. Now, these have been through a couple of updates. This is the latest series of definitions. We have 100, which is conceptual, and it's often represented with a symbol or some other generic representation. It doesn't have to be recognizable geometry. 200 then is generic placeholders. And here it has to be, for 200, it is recognizable geometry, and it's approximate, though. Everything there is approximate and can't be relied on for anything more. 300 then is accurate assemblies, and this means that model element, if it's at LOD 300, it can be measured directly from the model rather than relying on stated dimensions or callouts. And 400 then is the detailed assembly. It's for fabrication, assembly, and installation. And very little in a model will ever get to 400. This is only for basically those particular places where you need shop drawings. So to get back with what Tony was talking about in the level of information need, for the geometry, we need detailed dimensionality, location, and appearance, right? So at 100, there's no detail. At 200, it's low, everything's approximate. It's high detail at 300, and then we get to very complex detail at 400. For the dimensionality, there's none at 100, and then everything's approximate at 200. It's accurate at 300 and 400. The location, usually an LOD 100 object will be relative. You could have a symbol located absolutely, but it's probably not reliable. At 200, it might be relative or absolute, depending on what stage you're in the design. At 300, it's going to be absolute. You need that located. The location is stated in the definition to be accurate, so it needs to be located absolutely. And 400, of course, is absolute as well. The appearance, again, 100 is symbolic. 200 is really recognizable geometry. I need to be able to tell whether it's a beam or a floor. And then 300 is realistic geometry, as is 400. So the thing is, we are talking about level of development rather than level of detail. And there's a very important distinction. Level of detail is really the quantity of detail. So if we look at this structure on the right, the level of detail is pretty high. It looks like specific steel shapes. It probably is, because I probably took them from a library, and I can measure the locations of those precisely, but should I? I mean, have the shapes been engineered? Have they been located in their final location? We can't tell by looking at the model. Okay? This is where level of development comes in. Level of development is the reliability of the detail. Okay? So it answers these last two questions. At LOD 200, no, they have not been engineered and they are not in the final locations. At LOD 300, the answer to both is yes. So at LOD 200, it's approximate, 300 is accurate, but you cannot tell by looking at the model. You have to know what the LOD is. So these definitions were all well and good, but we found that in practical application, they were pretty widely interpreted. So what I think of as an LOD 200 door might be something different than what you think. So we got a group together in the BIMForum and came up with this LOD specification where we interpreted various building systems at various LODs. And this becomes a dictionary where you can look, if I want to know what a column base looks like, I can look it up in here, and here it is at 300 and 350, okay? And this is available free of charge at bimforum.org/LOD. In doing this specification, we found there was a need for an interim LOD between 300 and 400. Here's a steel connection at 300. All the members are there, they're accurate. And here it is at 400 with the studs and the clip angles and the stiffeners and everything else. We have a need for something in between if we're doing precise coordination. If we've got some pipes coming through this joint, we might want to see that gusset plate, but we don't need all the rest of this stuff. So we came up with this LOD 350, which would look something like this, and slipped it in here between 300 and 400. And here we're saying that it's pretty much the same as 300, except its quantity, size, shape, and location when interfaces with adjacent or dependent model elements can be measured. So, for example, a slab edge at 300 would be accurate in thickness and location. At 350, it would have the embeds for the attachment of the curtain wall. It's important to note that 350 is kind of a breaking point. We intentionally stayed away from embedding who did the modeling in the LODs because they can be pretty much modeled. Most of them can be modeled by everyone. 350, though, usually requires craft knowledge. So 350 is usually going to be done by the subcontractors, and the designers will usually not go beyond 300. So the coverage is buildings currently, vertical construction. We're in the process of extending it to horizontal, but that's underway. We use Uniformat 2010, which divides the building up into 7 locations, okay? We also use OmniClass, which is a one-to-one correspondent with Uniformat 2010. They're both published by the Construction Specifications Institute. OmniClass, though, is a more internationally accepted version, so we use them both. Now, why are we using Uniformat rather than master format, which is the format that everyone is much more familiar with, where we break down specifications? The problem with master format is that it is trade-based. So we have trades, all the trades impinging on this exterior wall. But what are you going to call, if you have a model element that is the whole exterior wall, what are you going to call it? What number are you going to put to it? There really isn't an answer. And also at the beginning of the project, you're probably not going to know that it's brick veneer. It might be EIFS, it might be metal cladding, whatever. Okay, so we don't know, and we need some designation that tells us what it is without knowing exactly how it's going to be built. So the Uniformat puts that whole wall as one number, B2010. Okay, so if you've got a wall that is one element in your model, you can label it B2010, or you can break it down into 3 layers. And most model authoring tools come now with this coding embedded. I believe it's the assembly code in Revit. It's called something else in others, but it's usually right there already. So it works very well for defining model elements. So the organization of the spec, there are 2 parts. Part 1 is the LOD definitions and interpretations. And that's where we get these kind of of pages. There's about 200 pages like this, where if you want to if you want to know what a steel or concrete beam looks like at the various LODs, here it is. So a little bit about the creation process, just to show how we got this well accepted across the industry. We begin with domain experts, and these are people from a particular discipline. And we always make sure that we have a designer and a builder on each domain expert group. They come up with the first draft of the definition or the interpretations. And then it goes to the core group, which is basically the co-chairs of all the domain expert groups, and it includes a designer and a builder from each discipline. So we go round and round and revise them until everyone can agree on it. And then the first time we publish it, we put it out for public comment. And then we get the comments back, and we will send them back through the process to revise anything that needs it. And it might go all the way back to the domain experts. Once that's revised, then we publish the final version. So basically, at this point in the first draft satisfies the domain experts, and here, as we revise it, we get it to where it satisfies everyone across the industry. Now, it's published annually. We add new content each year, but all the versions are kept available at bimforum.org/LOD. So if a project starts up, say in 2019, signs up to the 2019 LOD spec, attaches it to the BIM execution plan or the contract, they when 2020 comes along, they have the choice then of updating to 2020, or they can stick with 2019 if they want, because they know that's always available to everyone. Now, it's important to note a couple of key points about this. One, this is not a set of requirements. We don't, the LOD spec doesn't say, for instance, what LODs are in a design development deliverable or so on. It's really a dictionary. These are words, okay? And the user writes the story using these words. Okay, so how do you write that story? So that's part two, this model development spec template. Okay, so when we're dealing with models, we know that they grow from a conceptual up to a very detailed model. And we hit certain milestones along the way, probably something like concept, SDDD, and CD. And we also have a bunch of other models or model uses. There may be design reviews, there may be cost checks, we may be using them for simulation like structure and energy, and then we might have some deliverables at the end of the project for the owner to use in asset management. So this template then, it laid out like this. The building systems are in the rows, laid out by Uniformat 2010. The milestones, deliverables, information exchanges, and so on are in the columns. So each set of 3 columns defines a model, a specific model. Now, each model then will have a level of development, and it'll also have a model element author. That's the who. Okay. And it also has a column for notes, because we couldn't get everything defined across the board. So there are ways to put in specific notes. Now we'll get into the definition of this model element author in a minute here. But meanwhile, some of the terms that are used in this model development spec are, first of all, there are BIM uses. Most of you are probably familiar with that. And the BIM uses will have milestones within that use where we need to exchange certain information. So these milestones can also be defined through this process. We have specific milestones. There are standard milestones, SDDD, and CD, and we can also define interim milestones such as 50% schematic, as we're seeing here. Then there are BIM use or information exchange milestones, which we just talked about. Here's a milestone for the coordination. And this is the LOD profile that you need in order to be able to use that model for coordination. Now, the model element author that we talked about is the person who is responsible, or the entity that responsible for modeling the element, not necessarily the one who is responsible for designing it. Who's responsible for the design is still determined or defined by state licensing laws. Okay. An example of this might be early on when we were starting to do MEP coordination. The trade contractors were modeling things and the engineers weren't. So basically the trade contractor became the model element author, but the design engineer was still responsible for the design. So some logic. Elements aren't all modeled the same. Okay, you see in any model, you'll have a spread of LODs. So and then the LODs are not defined by design phase. Okay, 100, for example, doesn't mean SD, 200 CD or DD, and so on. Rather, the design phases are defined by an LOD profile. So at 100% DD, you will have elements at these LODs. By that same logic, there's no such thing as an LOD, for example, 300 model. You'll see in any of these models, there are a range of LODs. Okay. Now, LOD also is not a value judgment. 300 is not necessarily better than 200. Okay. Sometimes if we're in a design build project, for example, a design bid build, we want to leave that LOD at 200. So the specification is up, the selection is up to the contractor so they can get the best deal. And in that case, 200 is better than 300. Now, LOD does not indicate who authors the element. I mean, here you can see a 200 authored by the architect, one by the engineer, and one by the subcontractor. That being said, remember what we talked about with LOD 350. That usually requires craft knowledge, but we don't require that. We don't state that requirement here. If the architect, for example, has a trade contractor on board, they might be modeling it at 350. So what's it good for? In general, this framework defines deliverables, milestones, and information exchanges. It defines models specifically for these purposes. And it also enables reliance, because now we can tell what elements are accurate and what are just placeholders. So Tony showed this diagram earlier, and what happens here is if you look at the model element table, the model development spec, whatever it's called in the project, you'll see that the why, the process, is indicated right here. We have some standard milestones. Here we have structural analysis. Here we have the GMP cost estimate, and so on. Okay, so that's the why. The when is stated by a date, when that particular model is going to be delivered. The who, of course, is the model element author. And then the what is the level of detail number, level of development number for that particular element. So now most of the objections that I have seen from to the LOD framework have said that they don't address these things. I think they seem to come from people who have only looked at part one and have not looked at how it's actually used. Okay, so one way this is used then is in a collaborative work plan. Okay, we start by setting out a baseline. A lot of architects or engineers, whatever, will define what they mean, for instance, by SD, DD, or CD. That's their baseline. That's business as usual. Then, so they may tweak that for a specific project. And then independent of that, they will define what they need for specific BIM uses. Okay, for design, here's for design construction, design coordination, and construction level coordination. These are the LODs that are needed on these elements for these exchanges. So then we can look at where these fit into the overall design process. For example, we're saying that we need the design coordination to be done by February 1st. So if we sort this in by date, it comes in here, and we can see that the LODs that are necessary for the design coordination are not there at the completion of DD. Okay. So then if we look at when they are we have to move it out to here, but then we're getting it later than we wanted it. So the point is that we have a choice here. We've got all the information we need to make that choice, whether we're going to leave it here and accelerate the design of some of the elements, or we're going to take it out here and accept a later date. Okay, then if we look at the construction coordination level, we see that we need some additional modeling. So a lot of these elements, remember, the designers usually don't go beyond 300. The trade contractors will often need 350. So this is where the trade contractors come in and start advancing this model from a design model to a construction model. And that process is usually taking specific elements from 300 to 350. Okay, so adoption of OpenBIM. How is this actually being used? The U.S. State Department Bureau of Overseas Building Operation. This is the division of the State Department that builds the embassies. They're in the process of adopting OpenBIM, and so they have their alphanumeric information defined as COBie deliverables. Then the geometrical information, first of all, the model format has to be IFC as well as native. And then they use the BIMForum LOD framework to define the specifications of the model. They have what they term a minimum modeling and data requirements spreadsheet that the modeling requirements tab is a customization of the LOD spec part 2. Okay, so they define the design phase completions, and this matrix, then this spreadsheet is attached to the contract. So this becomes contractual requirements that they must deliver models at certain LOD profiles at certain milestones. It also is able to define the delivery model. They have specific different MMDRs for a design bid build project and a design build bridging project. And they're fairly similar, but they're a little bit different to facilitate that delivery model. And then they've also combined it with, if anyone is familiar with the U.S. Institute of Building Documentation and their level of accuracy specification, to define the scope for reality capture efforts, laser scanning, and so on, for specific use cases.